Ever wondered how scientists organize the diverse world of elements into one neat table? Our journey begins in the year 1869, when a Russian chemist named Dmitry Mendeleev made a groundbreaking discovery. He noticed that when elements were arranged according to their atomic weight, a pattern emerged. However, the modern periodic table is organized by increasing atomic numbers. By the time Mendeleev proposed that arrangement, he did not know about isotopes. This pattern, or periodicity, revealed that certain properties of elements recur periodically. Mendeleev's table was far from complete, but it was predictive. It had empty spaces for elements yet to be discovered. But Mendeleev didn't just leave these spaces blank. He predicted the existence and properties of these undiscovered elements. And as time went on, his predictions were proven correct, time and time again. This was the birth of the periodic law, the understanding that the properties of elements recur periodically when arranged by atomic number. Mendeleev's groundbreaking work paved the path for our understanding of the elements today. Pause the video now and think of what is the difference between the organization proposed by Mendeleev and the current organization of the periodic table. The periodic table isn't just a list. It's a powerful tool for understanding the behavior of elements. Now let's delve into the organization of the table. It's divided into groups and periods. First off, groups are vertical columns. Elements within the same group share similar chemical properties. This similarity arises because they have the same number of valence electrons, which are the electrons in the outermost shell of an atom that determine its chemical behavior. The Roman number for the groups represents the number of valence electrons. On the other hand, periods are the horizontal rows on the table. Elements in the same period have the same number of electron shells. These shells, like layers of an onion, house the atom's electrons. The number of these shells impacts the energy levels of the electrons and consequently the element's properties. Our current periodic table has 7 periods, which means elements with up to 7 energy levels. Pause the video now and answer the following questions. Question 1. What element is located in group 8 and period 2? Question 2. If an element has 4 energy levels, to what period does it belong? So, the table's design isn't random. It mirrors the atomic structure and chemical properties of the elements. Understanding this organization helps us predict how different elements will behave and interact. Did you know you can predict an element's properties just by its position on the table? It's like having a roadmap for all things elemental. Let's start with density. As we move across a period from left to right, the density generally increases. This is due to the increasing atomic mass. Next up, melting and boiling points. These tend to increase as we move from the top to the bottom of a group and decrease as we move from left to right across a period. Pause the video and answer the following question. Which elements tend to have higher melting and boiling points, metals or nonmetals? The atomic size, on the other hand, decreases as we move across a period from left to right and increases as we go down a group. Now let's talk about chemical reactivity. It varies interestingly. For metals, it decreases across a period but increases down a group. For the nonmetals, the reactivity trend is the opposite. Halogens, or group 17, is the most reactive group, with fluorine as the most reactive nonmetals. Noble gases, or group 18, is considered unreactive. Lastly, metallicity also shows a trend. It decreases as we move across a period from left to right and increases as we move down a group. These trends highlight the periodic table's power in predicting element behavior. In just 4 minutes, you've journeyed through the history and intricacies of the periodic table. We've seen how Dmitry Mendeleev, a Russian scientist, meticulously arranged the elements into a table, a puzzle that painted a picture of the universe's building blocks. This ingenious table isn't just for show. It's a treasure map, guiding us through the landscape of elements. The vertical groups and horizontal periods aren't arbitrary. They're signposts indicating similar chemical behaviors and atomic structures. Currently, our periodic table is organized in order of increasing atomic number, where elements with similar chemical properties fall within the same group. We also dove into the trends that ripple across the periodic table. From the density and melting points to atomic size, chemical reactivity, and metallicity, each trend tells us a unique tale about the elements. Yet, this is just scratching the surface. The periodic table is a portal, opening up a world that's waiting for you to explore. brimming with the fascinating stories of elements and their interactions. Remember, the periodic table isn't just a chart, it's a story of the universe in elemental form. Also, with your next assignment, Dr. Alex expects you to learn more about individual elements, their properties, and their uses. Enjoy this unit.